Welcome friends, thank you for coming in my YouTube channel. My name is Alex Artieda, Hotel Bravo 9 Delta Radio India. And in this offline workshop, I will present to you the AnTrack-Pro, my new antenna tracking system dedicated for EME, moonbounds, amateur radio astronomy and amateur DSM. I hope you will enjoy it. And if you have any question, because this is an offline workshop and not an interactive Zoom or Teamworks session, I will request to subscribe to my channel, give me thumbs up, send me your information or your questions via the chat, or if you know my email address, you can contact me. Okay, let's go talk about the presentation today. The agenda today is the introduction, what is happening now. We will have several open points. It's a theoretical presentation here now. And later on, that will be around 20 minutes. And later on, we will drill directly in the AnTrack-Pro. I have the AnTrack-Pro together with me here running, ready for the demonstration. I have 2 units on my desktop. And I will need to accommodate the video camera properly to do that. And later on, in the interaction, you will be able to drill together with me in every single menu and every single functionality the AnTrack-Pro has. We will talk about evolution of tracking systems, a little bit the story, radio amateurs, why tracking systems, how, a little bit. I will not dedicate myself a long time to this topic, but it's good to understand a little bit what is going on. Because the antenna controller is a sort of computer, we will talk about PC versus standalone, understanding for PC any kind of personal computer at home, not only Intel clones or IBM clones. That means that could be Apple, that could be other kind of hardware. And we will talk specifically in the part of the AnTrack-Pro, the definition and the philosophy to design a new antenna controller. Why a new antenna controller? We will talk about the characteristics, and in the implementation we will have the interactive session with the AnTrack-Pro. Will be a little bit longer, it's around 55 minutes. I already did that part, but really I recommend that you sit, place yourself comfortable. If not, make a pause, bring a glass of water with you, and take notes. And if you have any questions, I will be offline, available to you at any time to answer any question you could have. And finally, we will talk about production cost and deployment. People is always interested, when will be, how much it costs a fortune, it costs a liver, it costs a knee. Anyway, we will see also the production and the deployment part at the end of the presentation. Okay, let's go talk about the evolution of tracking systems. Yeah? Amateurs, we characterize because we create innovative solutions. Normally, we cross very easy, for good and for bad, the boundaries of the formal science. As I say, for good and for bad, we are able to cross these boundaries. And when the boundaries are crossed for good, we become with a very innovative solution where they help sooner or later, somehow, the regular traditional science in the job. Many developments and many nice and clever ideas evolve and born on radio amateur communities, small communities dedicated to a specific topic for many, many years. In that way, because we liked to create innovative solutions, mainly because we don't have an extensive budget and we are limited in our resources. We cannot compare ourselves like university, etc., etc. If we talk about tracking systems, well, tracking by hand was the big contribution. And for many years, radio amateurs tracking satellites and celestial bodies by hand. Even today, I'm seeing some of the expeditions they use, and they pull ropes here and there because they have two jaggies with, I don't know, 20 degrees beams aperture. That means they can have 10 degrees error and they are still aiming the antenna into the moon. Tracking by hand was always welcome, for sure. Low Earth orbit, you can do by hand. You can have the handy in one hand, and you can have your cross jaggy VHF, UHF in the other hand, and you can point and you can make QSO with the ISS or anyway with another station. That means tracking by hands was always welcome, but the cameras was better. No? In the 70s, many radio stations incorporate cameras to track in the moon, and they put the camera with the target, and they aligned the camera, and when the camera was entering in the moon, they aligned. But of course, tracking the moon with the camera is working only when the weather allows you. The weather not always cooperate, and the weather not is always nice. And during the day, forget it. You cannot use, because the moon is barely visible in the early hours of the day, and after 10 o'clock in the morning, due to the angle of the sun, is impossible. The reflection of the sunlight in the moon is lower than the intensity of the sun over you. That means it's not only the weather not cooperating, it's not a 24/7 system. Anyway, but at the same time, in this evolution of tracking systems, the computer touched home. And I'm making a very crash and accelerate pass over the history of computers, and you have the upcoming ZX80 microprocessors. My first computer was a Sinclair ZX Spectrum, I remember, connected to the TV, very small. And then you have Atari and Commodore 64, and why not the Apple II? And in parallel arrive all the PC clones from IBM, the 286, 386, 486. We are talking about 4 megabytes of RAM at that time. And then the Pentium arrived until our days. Last but not least, standalone PICs and microcontrollers also start approaching the radio community, and the people start to offload very simple tasks from the PC to dedicate PICs and dedicate microcontrollers. They don't need a hard disk, they don't need to have a big amount of RAM to run a very simple routine. For example, traditional implementation with a PIC, a sequencer to commute your antenna from TX to RX and RX to TX in a sort of events to not destroy the power relays due the switching the relays on hot, and so on and so on, and many other implementation, decoders, etc., etc. And then in this evolution of the tracking systems, many programs start to work on that limited microcontrollers and PICs. And then Linux come, and the open source and the promise of the free world in computing arrive. And last but not least, light platforms like Arduino, Red Pitaya, Odroid, Tinsy, Beagle, and many other more I cannot mention here, creating a plethora of surface in hardware where you can put your code and you can run, in some cases, more or less efficient than compared with other solutions. But definitive tracking systems, from tracking the moon by hand to tracking in an automatic system today, evolved thanks to the introduction of the PC and of the computer power in our lives, happening this one in the late 70s, 80s. And then we have the constantly dilemma if we say PC versus standalone. When I say PC, I mentioned, and I'm talking about anything that is a computer that runs self and has its own memory and over processor. Could be an Apple, could be a Linux running in some sort of hardware, could be a PC clone with Intel processor whatsoever. Yeah. Standalone, I make more reference to low-grade PIC controllers and microcontrollers, while they are capable and powerful enough to run just the enough amount of code they need to do one or two or three single specific tasks. Okay? And because the PC was introduced in our radio and evolved not only to do some gaming or stuff, the excess of power we have in that computers help us to develop programs, and a plethora of programs start to appear. You have programs to manage your QSL cards, calculators to calculate the size of a dipole, to design an antenna, ohm law even, software to calculate toroid and coils, and simulation software to do simulations in electronic circuits. When the sound card was introduced, the modulators, remember the first RTTY demodulators with the sound card running in DOS? And why not? All this stuff arrived sooner or later to a tracking system, and mainly for satellite operation. I remember one of the most successful softwares used for years was running under DOS and required very, very low power. It was AnTrack. AnTrack, and the latest version was version 1.54. I'm still having and I'm still running in the DOS emulator in my Windows computer. That means the satellite tracking profit for the excess of computational power, very, very good. But also some standalone solutions start to appear. Now, those programs, quite are very popular, especially for tracking satellites, they love to use a PC because they love to run complex calculations. They like to do not only the orbit calculation, they give you many other functionalities, additional graphic interface to see where the satellite is, or even where the moon is. But that demand run complex calculations, and complex calculations cannot be run when you are limited in the number of bits your microprocessor have, or in the speed of your clock, or in the amount of RAM you have available. Now, this introduction of PICs and microprocessors speed up the development of standalone solutions and cut a little bit the dependency with the PC. But they limit what they can do. You want to track, you track. And that's all. But today is demonstrated that you can track and you can make many other things, and some clever solutions start to appear. So, okay, let's go. I cannot run a GPS on my controller, but I can create a GPS unit and put this unit in a PIC, talking with my controller to upload the data on the controller. And that happens. I did. I implemented the DRI GPS1, was the standard GPS board used to upload GPS data into Oscar Echo 5 Juliet Foster Lima antenna controller. It was created, was my creation, my invention, but implemented by Andy Talbot, who managed the code and did all this stuff. And many clones and many copies exist on the market for that. That means everything is okay, everything is nice. We can add to these standalone systems running in limited microprocessors, PICs, but exists a big but. And the big problem is those standalone systems lack in powerful resources and have limited computational power. just someone are doing basic floating point calculations. If you don't have, if you are not able to do floating point calculations, you are not able to manage so much decimals, maybe 1 or 2. But sometimes you need to manage 6, 7, 8, 10 decimals, and that demand a much more sophisticated floating point calculations. And for that, your microprocessor or your PIC must be prepared. You need to have the right bit resolution, you need to have the right speed on clock, the right amount of RAM and SDRAM, and some divisions in the memory to allow the speed up in the calculations. That means the problematic is those standalone systems can do the job, but they sacrifice the user interface, and they have a very poor user interface, and it was not possible to implement better because that demands more resources. All these extra functionalities are not nice to have today. I will say, for me, are elements I'm using. That means somehow my dedicated antenna controller is linked with many other subsystems. And I finish with a box here with many other boxes and power supplies and everything, where when I am able today to run everything in this, a dedicated, powerful MCU unit. And we will see the AnTrack-Pro in details. I want to stop here and just mention one thing. One of the other problems when you talk about this PC and standalone, in the standalone, many times we need to run with microprocessors what they are. The operative system is a very efficient, very clever, is doing 1, 2, or 3 tasks, nothing else, but they are cyclical. That means if you have, let's say, 20 different steps, 20 sub-programs, let's go sub-programs. One program is tracking, the other is changing the year, the other is changing the day, the other is changing the etc., 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 changing the latitude, changing the longitude. Most of these ones cannot do grid locator calculation. That means you must know your latitude and longitude. Today, no, today you just put your grid locator, and with the grid locator, the antenna controller, in this case the AnTrack-Pro, can do the calculation automatically. You can invoke these routines, jumping from one to another without following a cyclical pattern. That means if you are in number 10 and you want to go to number 15, you must go first to 11, then to 12, 13, 14, and then you arrive to 15. And when the cursor is there, then you push another button and then you start to modify the parameters. With the AnTrack-Pro, forget it, because we are using a completely different approach. You can invoke with the touch buttons any subroutine on the entire package, on the entire software, on the fly, and you don't need to go in this cyclical. And that creates a GUI much more rich, easy to use, and much more comfortable. That means dedicated microcontrollers, the old technology, sacrifice and use a poor user interface to keep resources, valuable resources, to run the code. But today is a different story. Let's go talk about the AnTrack-Pro. What is the AnTrack-Pro and what is the definition and the philosophy? Well, it's very simple. We are moving from this to this. I need an explanation. We are moving from a 24 LCD display with just 80 characters and 4 push buttons with cyclical navigation, running at 8 bits, 10 megahertz CPU, with limited 64 kilobyte flash data memory. When we are moving to a device capable to run in a touch screen, a color touch screen with 153,000 pixels, with no push buttons, no cyclical navigation, that means I can go to any sub-menu directly, running in a 32-bit dual-core microprocessor at 240 megahertz with up to 16 megabyte of flash data memory. The ESP32, this is the core of the AnTrack-Pro, starting 4 megabytes, and you could order up to 16 megabytes. At the moment, we are running in 4 megabytes. In 4 megabytes, we are approaching the limit of the memory. Probably we will need to go to 8 when we finish to implement all the functionalities. Now, compare the code of what means running 64 kilobytes and running 4 megabytes. That means you have much more space and you have much more powerful. I will not explain you what is the difference to compute and do floating point calculations with an 8-bit and 32-bit microprocessor. I think so. You will understand that is a quantum leap step. That point to us to start to talking about the characteristics of the AnTrack-Pro. Okay, we are now in the 21 minutes. I hope in 10 minutes more we finish and we can go straight to the demonstration. This is a standalone antenna controller based on the ESP32 board. I already mentioned the characteristics. That means it's a 32-bit dual core running at 240 megahertz up to 16 megabyte flash of memory. It has a graphic interface designed with GUI slice under the MIT open license. That means we use an open source, is an open license. Mathematical calculations and dependency libraries are 100% proprietary of LinkRF. The firmware is not an open source software. We use just a limited number of libraries, especially for the graphic interface, and all under the MIT open license. Quite force me to inform the community or the people who is using or who receive or who decide to use this one, then they can use, and this is an MIT open license, but I am not forced on a way to disclose the entire source code of my project. And this is why I say, thank God, this is not a 100% open source project, because if you use just a small portion, all the other job must be free. And existing too many bad stories about bad people taking advantage over the job of other ones. That means I'm happy that I found my business model and my licensing model in the MIT open license. And more on that at the moment when the AnTrack-Pro will be available. The mathematical calculations to do the calculations of the moon position, etc., that was the heavy part. We need to design this one from scratch. We need to learn mathematics. We need to learn astrophysics. We need to learn how this one works. We read and see and we compare, and at the end we write the essential, because the problem with libraries is sometimes the library is this size and you just need a small portion like that. And if you understand the concept, you can write your own code. And this is what we did with the mathematical calculations. But the license, the libraries use it on the graphic interface. I think so. And in the GPS also, they are all under MIT open license, and feel free to go and investigate on that by yourself. Okay, it uses a 4 inches color touch screen. I was inspired the day I received my Icon IC 9700, but it has a 4 inches screen. exactly the same. And I said, oh, but that will be lovely to have an antenna controller with this kind of a screen. And at that time, the AnTrack-Pro was already on the way to be developed, but we didn't start the GUI. We just started building the libraries and building the mathematical calculations and see the results on the terminal, printing on the terminal the results without any GUI. Well, this 4-inch touch screen gives to us the possibility to have 153,000 pixels. It's so rich. I can run even the video, a full color video on that screen with a very nice resolution. I mentioned in the past that in my previous antenna controller, I built the 3 GPS unit to upload GPS data in the controller. And I finished with 2 boxes. I have the controller in one side and I have the GPS unit in the other side. Well, this time I said, no, I have enough powerful in the ESP32 board. Let's go put a GPS. And I decided to use the Neo M8N. It has a concurrent reception up to 3 GNS systems, GPS, Galileo, GLONASS, and Baidu. Some combinations with a little bit more limitation, but that means I can run GPS and GLONASS. If GPS is not available, I have GLONASS. If GLONASS is not available, vice versa, GPS helping me, and also Galileo. It's a very sensitive GPS. The antenna doesn't need to be 100% on the garden or outside. If you have a medium-sized window close to you, it's enough to retrieve the satellite information. The system has an embedded Wi-Fi module, and because it has internet and it has a lot of space, it has also a web server. You can query the IP via port TCP/80, and you could have a web server, and this is a perfect tool to do a remote control. And I will demonstrate that the AnTrack-Pro doesn't need any additional software to manage remotely. I will be very happy to integrate the AnTrack-Pro later on with other commercial softwares, and we are on the process. I'm discussing with the 2 or 3 more popular software. They are interested. As soon the unit pass the stage of release candidate, I will deliver that units and they will implement completely for free support for the AnTrack-Pro. But in between, for example, in my previous antenna controller, I need to build the 3-track software. Quite sadly, was hacked by a bad amateur, and some bad illegal copies are spread now in the EME community, and many people, instead of helping me and pay the development of that unit, what it was not cheap, I didn't develop that software. That software cost me 2 antenna units, more than 1,000 euros to develop. And it was sold for 38 euros, I think so. That means to cover just basic expenses. But no, unfortunately, the software was hacked, and many people copy the concept and use the software illegally. That means, thanks God, now I can protect my development using an embedded web server. That's all. I don't need a third-party software. I give the functionality of a remote operation for free. And in the demonstration we will run a few minutes later, you will see how it works. It has also embedded an RTC module. The RTC has a deviation of 10 seconds per year approach, and it has a battery giving you no volatile up to 5 years, more or less. We are studying at the moment, it's not defined. This is the RTC we are using. This is a standard RTC you can buy for $5 in eBay. And this is very good, but exists a Swiss factory who delivered to us already an RTC, quite is even more cheaper. It costs only maybe $2. And you don't need a battery. It runs with a super cap. The super cap keeps enough energy to feed the chip for 10 days. And after 10 days, well, okay, you need to run your GPS or put manually your your antenna, your grid locator, and automatic your antenna controller is in that long configure. That will be fantastic because we will be out of batteries. Batteries are lithium. Lithium are a contamination factor, and it will be a little bit responsible. That means we are working on that, but for the moment we are using this standard RTC. What is affordable, and it works very, very good. We continue because the AnTrack-Pro has plethora of characteristics. Well, because I have the GPS and I have enough power and enough RAM and everything, is it why we don't build an NTP Stratum server? What is an NTP Stratum server? If you don't know, search a little bit. I make just small parentheses here. This is an NTP, a network time protocol server. It takes the data, time and date from the GPS string, and if you query with an NTP protocol in a specific format to this specific IP, he resolves to you and answer to you and give you the time. This is what Dimension 4 is using in many of the softwares, synchronizing the clock of your computer, because if you are devoid of digital modes, the clock of your computer must be accurate, and is not accurate. Computer clocks, they drift. They drift sometimes hard enough to destroy your digital experience. That means you have an NTP Stratum server because you have already a Wi-Fi, means internet, and connection to your network. You will configure your clients on your network with your IP address dedicated into your antenna controller, and you will retrieve the time and data not from outside. If you don't have a GPS, then you will have always the option to invoke an NTP client. Yes, you have an NTP client, and you can disable or enable. If you don't have a GPS coverage, if you forgot the antenna, then you write the DNS name or the IP, whatever you want, for your external NTP server. Could be, I don't know, the Metas Swiss.metas.ch, I think so, is the Metrology Federal Office from Switzerland, and then I will retrieve the time from Switzerland to my computer, and in this case to the AnTrack-Pro, and he will synchronize his time. And automatic, he will host that time in the RTC. Well, you have predefined touch buttons, not push buttons, screen buttons by software, and you can quickly define targets like Sun, Moon, Sagittarius, Cassiopeia, Taurus, Cygnus, Leo, and Pictor. Additionally, you can display your home echo frequency when Moon is selected. For that, you need to enter the band you are operating. In a certain part of the setup, you must enter the frequency, because the echo and the Doppler is, the home echo means the Doppler is a function of the frequency, not only the distance of the speed that you are moving, if you are approaching or leaving. The frequency play a big role in that. That means you need to have the properly calculation. Additionally, if you are devoted of tracking pulsars or DSN or a specific, you can track any position entering random ascension and declination. And you can store this one in the controller and keep storing the controller, and you can invoke with just one touch. Last but not least, this is one of the most important parts we include. We include a tilt correction table for 60 azimuth predefined positions, each 6 degrees. Especially, this is designed for big dishes and setups where the verticality is not perfect. That means if this is the vertical axis of your antenna, and this vertical axis is still in this direction, well, that means when you are pointing to this azimuth, you have a less, your elevation is still down. But if you turn 180 degrees, in the other side, their elevation is still up. That means if you are not perfect vertical and you are tilted in some directions, your elevation error is erratic and exists the way to create a lookup table, and the AnTrack-Pro has a lookup table where you can plot every 6 degrees, and that the antenna controller will take in consideration that tilt table. The idea comes from me when I observed Danny in HB9Q installing his 10-meter dish, the new parabol solid dish. He discovered that in 10 gigahertz, small error in the verticality of the tower, quite probably is not an error, is the weight of the antenna, because the antenna weight more than 2 tons, I think so, derate and bend a little bit the system enough to create some tens of degrees off. Well, Sammy create, together with Danny, a lookup table to correct this, and they plot the antenna in 360 degrees. They create this plotting, and fantastic, it works great. That means I took the idea from the experience of Danny in HB9Q, and it's very good for antennas bigger than 3 or 4 meters, for frequencies over 23 or 13 centimeters. And if you want to really track seriously and have your system professionally deployed, is a very good tool. And we don't finish. Sorry. I hope this is the last slide of characteristics in the AnTrack-Pro. It supports 12, 13, 14, 15, 16-bit encoders. Easy to interface, like MAP25, ETS25, HH12, HH12 inclinometer. I forgot to add the HH16, quite is the 16-bit implementation of the HH12, and also the famous AC360 inclinometers. People ask me probably why the US Digital is not listed here. I don't see a necessity to work on the US Digital encoders because they are too expensive. Second one, after sold 600 of these antenna controllers, okay, I think so. If I found 6 or 7 customers with US Digital encoders, it was too much. That means doesn't make sense. I don't say it's not possible to implement, but it's not in my priority. And nevertheless, I don't have access to a US Digital. I'm not interested to buy a US Digital, spend hundreds of dollars in an encoder. I saw comparisons between the MAP28, the expensive Megatron encoder running in ball bearings, not in copper or brass shaft axis. We didn't find any difference between the US Digital and the MAP28, at least in the model they test. That means, for me, for the moment, the US Digital is a no-go. I'm open to discuss that with somebody if he's interested, but it's not my priority for the moment. And also, I don't work with the incremental encoders. I mean, this idea of counting pulses is nice, it's cheap, is even cheap than the absolute, but my personal approach, and please respect that, is the professional way to do this is, for me, is working with absolute encoders, and we have a plethora of characteristics, and I hope we will increment and increase the list of absolute encoders. Definitive incremental encoders are not on my list, and this is not for part of the AnTrack-Pro. We saw many other famous rotors, heavy rotors, having horrible problems with loose pulses and here and there. You just heard only problems with these incremental encoders. I know other people where they are working very well with incremental encoders. Happy for you, congratulations. But it's not for me, it's not for the AnTrack-Pro. Okay, use of a dedicated encoder board with microprocessor. Yes, this is another point, very important. Standard Antenna controllers, sometimes they are all integrated in a box. And that was my antenna controllers for years. And then I have the breaches and everything running on the shack. And I was forced to run in South Africa when I ran Zulu Sierra 6 Echo. My antenna was 92 meters away from my working position, but with all the bends and everything, it was 150 meters. When I installed the first time, well, no current was arriving on the DC path from the DC breaches on my shack to the antenna. And I need to increase the diameter of the cable 3-4 times to really manage the power I need on the engines. For that reasons, I decided that it will exist a microcontroller small board where a MAX 485 transceiver will send and receive the information, send and will receive some information for the bridges up to a distance of 2 kilometers. That means I can use a Cat5 table. My Cat5 table was running 100 meters, but okay, my Cat5 table in my old system was running 100 meters, but then I need to think in the DC cables, and I need 4 cables because they need to reverse in polarity. I cannot churn no one. That means I need 4 separate cables, big diameter, real estate, high, cost money. If you try to run large, that means I designed, and I saw this approach done by other people. That is nothing new for me. I saw other people use the MAX 485 as a transceiver to send the information to a small dumb microcontroller in the top who is just passing the information from the encoders to the central MCU unit. And this is the idea, and this is how we will do. The calculation resolutions are done at 0.01 degree, heavily intensive floating point calculations. The tracking resolution at the moment is in 0.05, the highest, maybe the more precise. I can play 0.01. That I need to then redo some libraries and some stuff on the mathematical part, a little bit more complex. But if you have the mechanics to run 0.01 tracking resolution, my congratulations. I don't see so often this kind of mechanics in our community, but it's totally possible. Of course, soft start and soft stop basically pulse width modulation that avoid the full power applied to the DC engines and move left and right. It will support DC electric engines. Let's say if you use the standard IBT2 bridges, they rated 30 amperes, I think, so they don't run more than 20, but 20 amperes is enough. They run around 32 volts. If you want some more cheaper because your engines use only 1 ampere whatsoever, you have plethora. That will not build by me. This is clear. Why I lose time to build this stuff when you can buy this one for less than $6 in eBay? That means don't make sense. Last but not least, we will have predefined offset for azimuth and elevation, making easy to interface with encoders. This is very important. You set up your antenna, you put everything, and you find in the orientation that you are 6 degrees in error in azimuth. Well, you have the option, you need to go up, and then you need to move the antenna, that's 6 degrees, and recalibrate and until you are in the point. Well, with the AnTrack-Pro, you will have a raw calibration for the setup where you can introduce that error, and that will be included in all the mathematical calculation, what is just sum and rest, to do the properly pointing of the antenna to the target you select. And finally, and this is very important, it will not be firmwares to distribute. I will not give firmwares. I don't want reverse engineering on this one. I will not share my source code. It will be available for a symbolic price in a final unit or in just a member of the unit. I don't know yet. I just smelling a little bit what will be. But for updates, the ESP32, based on the excess of capacity it has the possibility to do updates over the air. That means we can create a routine where you can trigger the update system manually. This is not Windows. Nobody will send you updates if you don't want. Nobody will update your controller if you don't want. You will trigger. You trigger the update, and you go, and the controller go to internet, go to my server, retrieve the item, the update, load the update, boot, and then you are updated. I expect not so many changes. That's why we have now almost 3 years in this development, and I expect to really do updates mainly when bugs are detected, and that is the mainly part. Okay, that was my presentation in terms of what is cooking and what is going on in terms of tracking systems and everything. And now we will jump into the interactive session with the AnTrack-Pro. Just wait for me 2 minutes. Okay, here is the AnTrack-Pro. You can see the different parts quite compose the antenna controller, and I will demonstrate how this is assembled and how this works. The core is the ESP32 unit. This is a microprocessor unit you can buy for $30 or even less. It includes a dual core Extensa 32-bit microprocessor, the LX6. Quite has in many different configurations in memory, with starting in 4 megabytes up to 32 megabytes. The internal memory is divided in many different forms. You have 448 kilobytes for RAM, especially for booting process. Another 520 kilobyte is the SRAM for data instructions that create a very, very fast response in the microprocessor. Additionally, you can assign 8 kilobytes of SRAM for a dedicated RTC or real-time clock, speeding up the booting process. It has an internal flash memory, as I said, can vary in different configurations. Additionally, we are using an RTC. This is a standard, the DS4140, I think so. This is a standard RTC you can buy for probably $3. I think so. The battery costs around $2 and or $1.50, and also the rest is the real-time clock. It will keep running with the battery and host the data of time and date. The other element included is the U-Blox Neo M8N, sorry. This is a very good GPS. Yes, the AnTrack-Pro includes the GPS, as I already explained. And additionally, one important part is the 4 inches touch screen. This is a very nice touch screen. It's a TFT 480 times 320. It's a TFT SPI 4 inches screen. And what I built, this is a main board. This is a main board or motherboard, or how do you call it, integration platine. It has some, in the prototyping, we make some mistakes that we need to correct with small cables. The idea is to glue all these
main components in the single unit. The shift levelers and the Max 45 transceiver is already embedded on the mainboard, and these are the connections for azimuth and elevation power modules, and also the connection with the remote unit to interface the encoders. Now, how this one works is very simple. We make an assembling here. The idea is to assembling everything in one unit. Okay, the mainboard is already connected. Okay, now we will plug the microprocessor unit. Microprocessor unit is already embedded. The way how the GPS and the RTC clock is mounted is just because this is a prototype. This will never be a final product. The idea is not to have this. The idea will be later on to implement these three components integrated in the mainboard, and it will be just a single mainboard, plug it and glue it with the TFT screen. Okay. It comes also with a very small antenna connector. This is for the Wi-Fi. Okay. And I will power up now the unit to do some basic demonstrations on the antenna controller. Now I just need to plug the respective power cable to the antenna controller. Oh, we have a mistake here. Yes, that's it. Hopefully nothing is blow up. Okay, here is the AnTrack-Pro. I will need to move a little bit with my hand to avoid some kind of reflections. Or otherwise I will stop the video and I will down the camera and put in a better position. Okay, here is the screen of the AnTrack-Pro running. I will do a test if we can try it. Yes, why not? I think so. It will work like that. Okay, I will explain in 4 lines. I will divide the panel in 4 lines: the vertical line, the upper vertical line, 2 middles, and the lower. And in the upper vertical line, you can see 2 red icons. The GPS red is in red and the Wi-Fi is in red. And this is mainly why, because first of all, we don't have an external antenna in the GPS, and the pulse on the GPS is not blinking. That means GPS is not locked, satellites are not locked, and this is a good indication of that. And the Wi-Fi means we have unsuccessfully connection with an access point because the SSID or the password are not correct. I will show you how it looks with another antenna controller. In this line, it's clearly what you are looking is azimuth and elevation. This is the position of the moon at this moment in Bangkok, today at around 0410 UTC. The home echo, the echo minus 45 is the home echo. You see the elevation is almost vertical. We are approaching 90 degrees, and the Doppler, the echo is just 46 Hz away from my frequency, configured in 432 megahertz. You will be able to configure different later. In the first line, what is important is the target. You can change the target just pressing your hand. And because we do a lot of sun measurements and we mainly work with moon, I decided to build moon and sun big buttons. That means I can back here to moon, or I can back here to sun. As soon as I select some, the echo, the home echo is 0 because we are not bouncing nothing on the sun and we don't have echoes on the sun. And in the same way, we can select 6 celestial bodies like Sagittarius, Cassius, Taurus, Cygnus, Leo, Pictor. Well, celestial bodies or positions on the celestial firmament. And every time you select, the controller show, you can use your finger or you can use the pen. Depends. Sometimes the pen is a little bit, demands a little bit more time. Sometimes fingers can be a little bit bigger. My ones are roughly like a hot dog's, but anyway, it works. For example, I select Casio and the target tells me Casio and automatically give me the azimuth and elevation where that target is. One additional element in this screen is the parking positions. We have 4 manual parking positions predefined. For example, I select parking 1, and this is the elevation and azimuth for parking 1. I can edit, I can enter here, and I can delete. I can put 1.3, enter, and then the correction is done. In the same way, the azimuth. And when I decide where I want to go in these 4 parking positions, I just accept, and the target say park 1. You see, I correct my elevation to 1.3 degrees. We can back to parking position. And you could have 4 different parking positions you can invoke in this manual point. You can clear and you just return to moon. I think so. The first line is explained by themselves regarding how it works. As you see, the encoder is the device is working very smooth in terms of calculations. We work a lot on the code to clean up because in the beginning we have some refreshing problems and we still need to fine-tune some additional elements. But as I say, this is the developed version number 9. We don't have even yet in release candidate, but we are very close. Now I will, after explain the upper horizontal line, I will go the second line. And in the second line, I have 2 sets of controls for azimuth and for elevation. That means the way how the position of the touch buttons are disposed is creating a vertical axis for azimuth and a vertical axis for elevation, where the upper part is the target and in the lower part is the antenna position. At the moment it's 0, 0 because no encoders are connected. And in the middle are the manual corrections I can do on the fly. That means if I'm looking my echoes and I am pointing the moon and I said, maybe I don't have a perfect match, I can correct in steps, in different steps. In this case, we are going starting in 0.5 and I will just cancel here. We can go in different steps in 0.5 degrees, okay, and that will help me to do a fine-tuning on the antenna when I am pointing the moon or I want to really deviate a little bit, few tenths of degrees from the target position. Now in the offset, what is important is this is a raw calibration for azimuth and elevation. That means you set up your antenna and then you try to put the antenna as better as possible. And then you discover that in azimuth, I'm not in north, I am plus 4 degrees respect to the real north. And then you can correct here, you can, well, an elevation of 9 degrees correction is not realistic. I will say 1 degree or 1.1 degree. Or even, I can say 0.5. With the finger, sometimes small numbers is okay. And with this one, you avoid hard manipulation on the antenna to find the properly north. Okay, then you can go and you can correct and you can fix via software what normally is a go up and down to the tower and moving the antenna, or somebody helping you with a handy or walkie-talkie, etc. And that creates an automatic correction, that automatic align all the calculations to respect to the offset. If you are a purist, if you want really to have everything set up at 0, then you can go and you can fine-tuning the mechanical part. But one important characteristic of the AnTrack-Pro is this tilt correction table. I don't see another antenna controller, probably I am wrong, sorry if someone's can correct me later, I will be very happy. The tilt correction table, it's a loop back table with 60 positions where the azimuth is divided in each 6 degrees. That means we have 360 degrees in 60 positions, each 6 degrees, one position. And we can enter a specific elevation because the tilt of the antennas, suppose this stick is the antenna, and this is the vertical antenna, okay? The antenna could be tilted, that generate in one direction, that generate that, for example, at 20 degrees, the antenna has an error of -1 degree elevation. But if you go 180 degrees, this is reversed. That means it's not the antenna has an error of down 1 degree. It will go up 1 degree in the opposite side. And that creates a real problem, especially in high frequency operations and with dishes more than 3 or 4 meters start to be a problem. We saw this one in HV9Q, and we have a loop back table also to correct the elevation on our 10-meter dish. Based on that experience, I decided to incorporate this table. This table, for example, you see a 90 degrees azimuth, the elevation has a correction of 1.2. You can delete this one, and you can put even a negative number, -2.3. Sorry, it's sometimes with my finger. Oh, I think so. We need to go here, yes, because we are, yeah, it was one space too much and I was not able. Again, I will say 2.3, enter. And now you see at 90 degrees, you have a negative correction of -2.3 dB. That means when the antenna controller is chasing the moon or the sun or the object you design, he consider this offset, okay, and he consider also the antenna correction to find the right position. That gave you a lot of flexibility to correct tilt problems in your antenna, okay? Okay, that explains the second line. The third line is very simple. You have the azimuth, that is the azimuth reading from the encoder and the elevation. I don't have the encoder interfaced with me. But one important part here is the antenna movement resolution. And this will tell you what will be the resolution. Here is 0.10 degrees. Okay, you can go from 0.05 to 1 degree in steps of 0.05 degrees. I can program in 0.01 degree if I want in the firmware, but honestly, I don't think so. People have enough good mechanical systems without backslash to work at that high level of precision. The AnTrack-Pro can manage, no problem at all. It manages 2 decimals. The resolution can go up to 0.01 degree, and this is one of the big advantages compared with the other antenna controllers. Why they are just limited to 1 decimal, making some non-precision calculations when you want more accuracy. Okay, you can clear, you can cancel, etc., etc. And last but not least, in the last line, well, the center, you have your UTC window. This is what you are reading. This is what you are reading, and in terms of time, this is the time and date. What is completely mandatory and sensitive information to have the properly antenna tracking successful. Here, what you are reading is what the GPS is reading every, I think so, the refreshment is every 5 to 10 minutes. The MCU reads the date and the time of the GPS. If the GPS is not available, like is now, and if you have configured your NTP server, your NTP client with an external NTP server, the system will go via the Wi-Fi connection, via the to internet, and it will retrieve the data and will store it in the RTC. In the same way, the GPS will recover the data, or take the data from the satellites, okay, and store it on the RTC. What happened is, now in this case, we don't have internet and we don't have satellite, but previously the RTC host already an information, and due to the battery presence, we can keep for 5 years the time running with an error of no more than 3 or 4 seconds per year. This is a very, very accurate RTC. That RTCs evolved in the last years compared with others. I remember that was one of my main problems with the Dryx G2, where you must adjust a capacitor, and that was not really so precise sometimes. Anyway, in this same line, you have clearly 2 positions, 2 switches, auto and stop. This is clear. Auto it will start auto tracking, okay? And if you want to stop, you just stop and the antenna will stop where it is. Now, we have 2 additional touch buttons in here. Manually, we can go to any manual distillation on fly. I can say azimuth, go to 30 or 323, for example, okay? And elevation, I will say 43. And then I say accept. And automatically, you see in the upper line, my target changed to manual, and I give azimuth 323, elevation 43. And if I am in auto, the antenna automatically will go to that position. I can select any position I want, okay? If I want to return, I return to moon. And automatically, the calculations are back to the main screen. And finally, we have the set. The general settings. This is a very interesting screen because Here you can turn on off your Wi-Fi, your GPS, your NTP server. This is one of the top characteristics of the AnTrack-Pro. Yes, and you can turn on your NTP client. Later on, I will explain a little bit more. Here you can select the band. That means you have bands selectable from 50 megahertz to 47 gigahertz. This is very important for the home echo calculation. The home echo calculation is based on the frequency. And if we give wrong frequency, we will have wrong echo calculations, okay? Well, I will continue here. The grid locator, Oscar Kilo 03 Golf Radio. This is Bangkok, Thailand. This is my home. And this is the LAT and LOT. This, because the Wi-Fi is on, normally, the GPS is on, and you turn on, it will go in the boot process, it will read your lat-long position, it will create the grid locator, it will show the grid locator, and it will use this lat-long to do the calculations for moon position or sun position. What happens if the Wi-Fi is off and you don't have GPS? Well, you can enter manually your grid locator, and automatically he will calculate the latitude and longitude. That means you don't have a GPS, you forgot the antenna, you don't have internet to know where exactly you are, but you know you are in the expedition in a specific grid locator. You just introduce the grid locator, and then you just generate the latitude and longitude used by the controller. Here, I was telling you that you have an NTP server. Yes, because you have a GPS. I decided to include NTP Stratum 1 server. That means when the Wi-Fi is on, sorry, I cannot move. It's a little bit tricky to keep on the air. When the Wi-Fi is running, your device is on the network, and you have computers on the network, and you go use dimension 4, you synchronize your time, because it's very difficult, it's very important, especially for the digital guys. At the end, the NTP server locally running take the information from the GPS, and because you have an IP assigned, could be a static or dynamic, you can query your NTP client from any computer, Windows, Linux, Mac, whatever you have. You can put your NTP client to the IP of the AnTrack-Pro, and the NTP server Stratum 1 will send the data about date and time, very precise. I cannot pass to the next screen. I need to switch, I need to change controller, and I will explain you why. Oh no, I can, because the Wi-Fi is not running on this controller. I will demonstrate later how it works. That means the next step is the network. For the moment, the Wi-Fi and the Wi-Fi SSID is shown, and the password is shown in clear text. That is why I try to run the other antenna controller, but this one is also not connected to the network. And as you can see, you don't have any IP subnet default gateway than DNS configured, because you are not connected. I didn't give the SSID and password, okay? In the lower part, to finish, you have the NTP external server. This is the IP of one of my internal Stratum 1 NTP servers running on my network. You can put any server, you can put even the name, you don't need to put the AnTrack-Pro has a DNS resolution. That means it will, you write pool, NTP pool.org, I think so, I don't remember exactly. Or you can introduce, for example, swiss.metas.ch, that is the Switzerland NTP server from the Federal Office of Metrology, etc., and that will be automatic. Okay, this is mainly the AnTrack-Pro. It has a very enriched experience on the menus, on the way you work. You can go to set, you can configure, you can select your encoders. In the encoders, I forgot to mention, I have for the moment absolute encoders 12 to 16 bits. Some people asking me for 15, 13 bits intermediate. I don't know if that makes sense. This is completely experimental. It's not yet defined. I want to be clear about something. I sold, means it's here. You remember this antenna controller. This is the Dryax G2. That is the implementation of Hannes Oscar Echo 5 Juliet Foxtrot Lima controller. I sold around 600 of these controllers. And anyway, I just want to stop here to mention that the way how the control works in terms of encoders is depending on what is the demand. I sold more than 600 of these antenna controllers supporting many rare encoders, old-fashioned 10 beats, and also the US digitals. And honestly, for all my 600 controllers I sold, if I have 5 or 6 persons running with the US digital, is too much. Okay, here you can see this is the traditional controller. I love this Oscar Echo 5 Juliet Foxtrot Lima controller. It was my, we have some error here on the loading because I think so the Spark and sometimes the firmware didn't upload. Now it's correct, okay? I have nothing connected. I worked for many years with this antenna controller. It's de facto my antenna controller, but that will be replaced now with the AnTrack-Pro because times change and the availability of much powerful microprocessors allowed me to build a more enriched experience on the graphic interface. As you see, the antenna controller is very, very robust, very simple. This is just a prototype. And I want to give you another experience. I have another antenna controller here where the network is configured. I will change antenna controllers now. Okay, I will just put this one, on hold. Okay, this is the other antenna controller. You can see now the Wi-Fi is not anymore in red because we are connected. This antenna controller is connected, okay? And if I am not wrong, the IP given by via my DHCP is 51. And this is what I want. The AnTrack-Pro has an embedded web server, and you can manage remotely if you are connected to the internet or to the Wi-Fi or to your internal network. You can manage from any computer. And I will do a demonstration. For that, I will host the antenna controller here, and I need to move my camera to my main PC, okay, to one of my monitors, the central monitor. And I will introduce the IP address of the antenna controller, what is 192.168.1.51, I hope. And yes, voila, here is. Okay, as you can see, I will place the antenna controller just close to the, and you can see azimuth and elevation is showing in real time what you have there, okay? The UTC is not shown because the interface is not finished. We must do, well, Fiji, then I think so 432. I will say submit. Okay. But and I don't want to go to network because it will show in plain text my password, and for security reasons I keep it like that. Okay, for the moment this interface is not finished, but it's very useful because you can keep in your desktop, no, and you can move to any position on your network, and you will have here a full control of your antenna controller. You can select the targets, the moon, etc. As I say, the web interface is not finished. It's just showing me azimuth and elevation as I demonstrate. But having I can place in another screen, and I can use my other screens to just place the working programs, and it will allow me to manage remotely. And this is, as I mentioned, this is an incredible advantage, because that allowed me to use the antenna controller on the network and managing remotely. You don't need any additional software, how it was in the past, or you don't need to create special commands or ASCII comments, or you don't need to send query and request and complicate numbers. You just open the web interface and you are in business. One additional stuff is I just place the antenna controller here, and I can take the other antenna controller. It's not yet a decision how we will manage, but for the moment, this prototype is completely you can assemble it, that is assembled. The core of everything is this mainboard. It's very simple. Then these three elements. These three elements quite are the MCU unit, the ESP32 with the dual microprocessor, the RTC, and the GPS. You can buy all this stuff for, I will say, less than $80 in eBay. And the screen, I think so, I pay something like $12 or $15 probably. That means the cost of this antenna controller is so reduced. Of course, it's 3 years of work on the firmware, and this is the last part of the presentation. This system was a real challenge for me, because when I start this one, I never programming more than LED off, LED on in Arduino. And George Bordeaux, my long friend from Canada, long time, he works with me in the IQ Plus project in the UADC4. He decided to go straight with this one, and we decided to create the AnTrack-Pro as the logical step, the logical evolution in terms of what we have today. So powerful microprocessor. That means for me, the times of peaks and 4 kilobyte memory are, or 8 kilobyte memory are on the past. And we was confronted with the reality that how we can manage. I have mixed experience with software. Unfortunately, the 3-track software I built for Hannes controller was hacked by somebody, and some illegal copies are somewhere. That really destroyed me, because it's not funny. I have mixed feelings also with the GPS interface I built for that controller. Was copied and it was never recognized by nobody. And one of the big problems is some bad copies of Hannes controllers was sold and presented like it was built by me. And honestly, I was so upset with that, because that people try to reach the free copy of the software telling that it's me. And I said, sorry, but look the photos of my controllers and look the photo of what you have, and you will see it's a big difference in the quality of the materials, etc. For that reason, and many other ones, I stopped building the Hannes controllers, and we embrace in the challenge to build the AnTrack-Pro. The AnTrack-Pro is built with some MIT with libraries running under MIT license. That means I must tell you which libraries under the MIT license I'm using. There are a few ones. Mainly the graphic interface is GUI slice and is running under MIT. But thanks God, under the MIT, I'm not forced. I'm not obeyed to develop my source code. Something I will never give. That means all the mathematical calculations for tracking the moon, the sun, and all the celestial bodies, etc., are the hard work we did by ourselves. We didn't copy or use any other library or whatsoever. That means, and then we was confronted with the reality that who is telling you the truth? That means Hannes controller is telling one thing, Moonscat is telling another thing, WSJTX is telling you another thing, and I decided to use Moonscat as a standard. Okay, it's mainly in 0.0 something degrees plus minus. We are very close on the mathematical calculations. I can show. Just I will give up again. Just 1 minute. I will back to. Okay. Here, I need to go a little bit inside. Yes. Okay. You can see elevation. We are calculating exactly the same as a moon track, as a Moonscat, sorry, and moon track in the window, and azimuth and elevation. It is showing me, depends on the object. It could be 0.05, 0.1 sometimes, 0.02. What I found is really so difficult and so critical to design. I never see two programs reading exactly the same, but I am very confident on my calculations. I test my calculations very well, and I'm pretty sure then, for example, we can go. I change to sun now, and we can. Let me see if I can change. Okay. No, I was thinking I can change here, but no, I cannot see. Anyway, I back. Okay, that is mainly the presentation. Okay, the controller is running in sun at the moment. Okay, we can go back to the moon. Yes, as I mentioned, the graphic interface here is not yet finished. That means it will be finished after the initial releases. Okay, we we really expect to have this one as an additional functionality. This is my presentation. I hope you enjoy it. This is a new YouTube channel I put because I have many other presentations for Lindred. I will update this presentation as soon we have the release candidate unit. I will do another presentation, and I will finish now here. Unfortunately, this is an offline presentation, not a Zoom or TeamWorks presentation where we can interact each other, but everybody knows my email address. You can try to contact me or subscribe in my channel and leave me a message with your address, and I will contact you if you have any question. I will regularly inform in Moonnet and via my homepage the evolution of the AnTrack-Pro. Thank you very much for listening. I receive many requests about when it will be. Just one single part I want to finish is don't call me for the firmware, please. I will not give the firmware or the source code because we invest on money and time here, and we want to recover at least with no profit what we did. The main job will be the main board. Quite is nothing complicated, and I will decide later what we will do. We have the option to embed all these three components on the main board. That means build our own microprocessor. That means just put in the chip, installing just the chip, because if this is the GPS, the U-Blocks chip is just this small square where you can see. The rest is additional interface stuff for the computer, the antenna, the connector, whatsoever. That means it's possible also the RTC. The RTC has used huge battery. We are evaluating a new RTC for a Swiss company. Quite doesn't use a battery. It uses a super capacitor, and it hosts the data and the time for 10 days, 10 or 20 days, something like that. What is more than enough, because as soon as you turn on and you boot with a GPS, everything will be updated again, or via internet if you're using your NTP client. I don't decide if I will use the DS4140 or if I will go for this Swiss RTC. Quite is even more cheaper than this unit. This unit probably costs totally $5 or $6. The Swiss RTC is much cheaper. It's below $2. That means one option is implement all this stuff in a one single main board, glue it and sell it. And if this is the case, my goal is to produce the AnTrack-Pro for less than $200. We don't have, and I didn't talk about the interface with the encoders, but just to keep on track, just 1 minute, the interface with the encoders will be done. These will be the standard bridges. This is also, you can buy in internet for almost nothing. And I will use another small Arduino, because we will use max 485 transceivers to have 2 kilometers longitude in a twisted pair. And a big change I can announce is the power modules. These are 30 amperes or 20 amperes power modules. I will derate it, but I will say no more than 20, because I think so it's very small, the heatsink. The power modules will be installed in a separate board on the antenna. It will not be on the shack, because one of the problems I have, and people told me when we deploy the when we deploy the Dryax G2, the people criticize me then they need to run long DC cables and big ones because they lose power with the distance. In that case, all the information about moving the encoders and reading the encoders, it will comes from the tower via the twisted pair we will use with the transceivers with the MAX 485. And for that we will need a small PCB with properly MCU unit there. Quite is irrelevant in the cost. Okay, I'm approaching 50 minutes of the presentation. I think so this is enough. I hope you enjoy it. I just want to finish some small words, and for that I want to just change my my camera. Thank you very much for the time being. Behind me, I don't know if you can see, behind me is my slew drive. This is the 23 centimeter antenna will be installed here, and the AnTrack-Pro will be responsible of moving. These are the DC cables, and the azimuth encoder is already embedded. It's a very nice system, and I will fire up with the AnTrack-Pro, and I will give in this channel my feedbacks and everything regarding how the system works and everything. I will search for a few 2 or 3 beta testers. I just want to finish this part. I'm those people who want to collaborate with this small project. I will send a unit completely for free, and with the condition that you must install it and you must test it and you must receive the properly updates in case, and you must give to us the feedbacks. No, that will be the next phase. We invest a lot of time in this antenna controller. It's really a state of the art. I'm so happy with the results until now. And just one little thing I forgot to mention. The ESP32 have the possibility to receive updates on the air. What means that? Not any more firmwares to update and complicate programs, and special programmers need to be attached to the controller. If you are connected, if your controller is connected to your Wi-Fi and you have internet, you will query my server, and my server will tell you if you have an update. And if you have an update, the update will be pushed. You will accept when you want to do the update. This is not Windows. We will not force nobody to update your controller. But you will not need to unplug the microprocessor, plug another cable or jumper or boot or whatsoever. Is update on the air. This is another functionality embedded in the ESP32. And I think so you really will appreciate that function. Okay, this is everything for my side. I wish you all the best, and I hope soon we will be able to deliver more news about the AnTrack-Pro. If you have any question, please don't hesitate in contact me. All the best, and thank you, my friends.